Hello students, today we are going to see something important and interesting topic, that is how to convert alcohol from alkene, from carbonyl compounds, and using Grignard reagent. How do we get alcohol, or how to convert alcohol from here to there? That is the point we are going to see, and it's very important topic and interesting also. Let us go for the alkene converted into alcohol. I'll give the hint. Okay, here we are using acid catalyzed. Okay, now here reduction process, carbonyl compounds, conversion of carbonyl compounds into alcohol, reduction process. Okay, so when you are talking about this point, how to convert, so you should remember the key points, so it will be easy. Reduction means what are the materials we are using. Acid catalyzed means what are the materials we are using to convert. So in such a way you remember. And Grignard reagent, you are using the Grignard reagent with carbonyl compounds. Okay, what are the carbonyl compounds? Aldehydes, ketones, carboxylic acid, ester, ether, all those things, carbonyl compounds I mentioned. The same way here, you are using the Grignard reagent along with carbonyl compounds, you are getting alcohol. Now here carbonyl compounds, how to convert from carbonyl compounds, it's going under reduction process, you are getting alcohol. The same way alkene converted into alcohol in that acid catalyzed. So one by one we are going to get a clear idea, then we'll go for the question wise answers. Let us go for it. Now here it's important to note down how do we get alcohol from alkene. That is 2 mark question. And one more thing, write the mechanism of alkene converted into alcohol. That is 3 mark question, mechanism they may ask, and so simple it is. Okay, it is acid catalyzed method I mentioned. Simple. Alkene example, CH2 double bond CH2. It's so simple. Combined with water in the presence of concentrated sulfuric acid, what you are going to get it? You are getting CH3 CH2 OH. So alkene reacts with water in the presence of concentrated sulfuric acid. Addition reaction takes place, you are getting alcohol. Okay, now what happened here? H plus OH minus ion. So OH minus ion acts as a nucleophile, and here you know which way it, because it is so simple. One thing it has to go there, another one, because no other way to go. It has to go and join here and there only. Only two are there, so easily, because it is a symmetrical, easily it can contribute. Suppose if it is unsymmetrical alkene, what is the product, how this formation it will take place, that is what mechanism we are going to learn. Okay, now for example, CH3 CH double bond CH2 combined with water in the presence of concentrated sulfuric acid. So what you are going to get it now in this place? H plus ion, OH minus ion. Now, can you guess this OH minus ion acts as a nucleophile? Where it will go and join? H plus ion, where it will go and join? Now you have to refer with Markovnikov's rule. What Markovnikov's rule tells? What is the mechanism it says? So OH minus ion, it will go and join. That is a nucleophile where it will go and join, where there is a lesser number of hydrogen. Right? Now, H plus ion, where it will go and join, where there is more number of hydrogen. That's all. Now, what is the product? CH3, CH, here OH, the bond breaks, here CH3. So, what is that? Isopropyl alcohol, you will get it. Unsymmetrical alkene means you are getting isopropyl alcohol. Whereas alkene, it is a symmetrical alkene, means generally primary alcohol you will get it, whereas here secondary alcohol you will get it. Hope you're clear. Let us go for the mechanism very clearly. This is alkene converted into alcohol. The same way here, propene converted into isopropyl alcohol. Propene, it is what it is, unsymmetrical alkene. See, unsymmetrical alkene, this side when you cut this side, CH2, here CH3 CH. So unsymmetrical alkene, is it visible? Yes. Okay. Now here unsymmetrical alkene converted into alcohol. What is the product? What kind of alcohol you will get it? So such kind of questions you may be aware of it. Okay. Now let us go for the mechanism. What are the steps for the mechanism? How to identify easily? We'll go for it one by one. Now let us go for the mechanism acid catalyzed addition of water to alkene. Okay. Now let us go for that. Actually, mechanisms means we have to follow some steps. It will be easy for us to analyze it. Okay. What are the steps to be followed? Formation of carbocation, attack to that nucleophile, and you will get that removal of proton. Finally, you will get the product. So what are these three steps? Let us go for it. First and foremost, formation of protonation protonation as well as carbocation carbocation. Okay, so how to get this? Actually, formation of protonation and formation of carbocation. First and foremost, H2SO4, we have taken what it is acid catalyzed, so this gives what it is H plus ion plus HSO4 minus, that is a proton, right? Okay, this proton combined with water, H2O, you are getting hydronium ion, H3O plus. So H3O plus, how to write it? Hydrogen here, hydrogen. This is a structure of hydronium ion. So this acts as a electrophile which attack that alkene to form the carbocation. Yes, in the first step, two things are there. First thing, it is protonation. Yes, this is protonation, addition of proton like, and formation of carbocation. So how to form the carbocation? This hydronium ion acts as an electrophile and attack the double bond from that alkene and form the carbocation. Okay, now CH3 CH double bond CH2. This is alkene CH2. Alkene combined with what it is? Hydronium ion. So what happened? This hydronium ion. So this hydronium ion breaks that bond, and this hydrogen which is going to attach over here. So automatically this bond gets diverted and it forms here water molecule. Here carbocation formation. So here what it is? CH3 CH plus, here CH3. So carbocation formation as well as water molecules. Water here, water acts as a nucleophile. This point, water acts as a nucleophile. And here the carbocation formation. What do we call? This is carbocation. Carbocation. Yes, got it. First step over. So in that first step, two things are available. First step and second step. First step, it is protonation as well as carbocation formation. Yes. Now the second step, what it is? Attacked by the nucleophile, which is acts as a nucleophile. Water only acts as a nucleophile. Though it is a water, it is a weak negative charge, then also it acts as a nucleophile. Carbocation, so CH3 CH, here positive charge CH3, here carbocation. Okay, so carbocation attacked by the nucleophile, which acts as a nucleophile. Water only acts as a nucleophile. Yes, this is attacks that nucleophile. You are getting protonated alcohol. What is it? Protonated alcohol. So here what it is? The second step, attack by the nucleophile. Attack by the nucleophile. Please note down, it's very important. So if you know the steps, no, easily you can identify. Yes, CH3 CH, here protonated alcohol, no, here CH3. So this is protonated alcohol. Protonated alcohol are very strong acid. So it is ready to leave the proton. It is ready to remove the proton. So this is OH. Two things are there. No? So one hydrogen, that means ion, it is ready to remove. One proton, it is ready to remove. So to form alcohol. This is what it is, protonated alcohol. Protonated alcohol. Protonated alcohol, a very strong acid. Please note down. Protonated alcohol, it's very strong acid. It's ready to leave one proton from there and form what it is? Alcohol. So this is the step 2, and now we are going to see that step 3. Yes. Okay, now let us go for that step 3. What is it? Step 3, removal of proton. Removal of proton. Okay, so what is it? So here protonated alcohol CH3, CH here O hydrogen, here hydrogen, here CH3. This is a protonated alcohol, right? And what happened? It's ready to lose one proton and it form what it is? Isopropyl alcohol CH3, CHOH, CH3. Right? So this is what it is. 3 steps. First one, formation of protonation as well as formation of carbocation. How do we get? You know very well. The second step, what it is? Attack by the nucleophile. So water acts as a nucleophile and that will attack the carbocation. This is the carbocation and form protonated alcohol. Protonated alcohol are very strong acid. It's ready to leave that proton. So it is ready to lose the proton and you are getting alcohol. That is the third step. First, addition of proton. Last point, removal of proton. So this is the mechanism. It's a 3-mark question. Please note down. Hope you are clear with it. Now, one more important question. How do we get alcohol from alkene through hydroboration? Okay, it's very important question and it's very interesting also. It is oxidation method also, you can say. Hydroboration, what is it? B2H6. Actually, this is nothing. It is a diborane. Diborane also. This is oxidation method. Now, we can take what it is? CH3, CH double bond CH2. Alkene only we can take. Anyway, the topic it is alkene converted into alcohol. So, alkene combined with the diborane BH3 twice. I just mentioned here BH3 twice. Now here B2H6. Here just I put it ulta. BH3 twice. This also the same B2H6. In the presence of aqueous NaOH. So aqueous NaOH in the presence of hydrogen peroxide. So hydrogen peroxide along with nucleophile. So what it leads to think as it is anti-Markovnik's rule, right? Yes, anti-Markovnik's rule only. Anti-Markovnik's rule, what it tells? Actually, alkene converted into alcohol in the presence of aqueous NaOH along with hydrogen peroxide. The same point I'm bringing here. So this is actually addition reaction. So addition reaction, now what happened here? What is the product you are getting? CH3, CH2, CH2, BH2. So you are removing that hydrogen and you are getting, this is the product. Now this product again it reacts with what it is? Alkene, that is excess of alkene. So here CH3, CH2, CH2, BH2 reacts with alkene CH3, CH double bond CH2. So what is the product you are receiving? The long chain structure you will get it now. CH3, CH2, here CH2, here BH. Okay, and here one hydrogen will be removed and again CH2, CH2, CH3 ulta. Okay, now this product, this is another product. Again it has to remove completely what it is? Hydrogen. So again this product which is reacts with the excess of alkene. What is it? Excess of alkene? CH3, CH double bond CH2 and you are getting what it is? Here CH3, CH2, CH2 thrice B. Thrice, 3 times, no, 1, 2 and one more time. It's 3, thrice B. And again it will react with hydrogen peroxide. hydrogen peroxide. Now what happened? Here you will get propyl alcohol, CH3, CH2, CH2, here OH. And what is the product you are receiving? You are getting H3BO3. So that is orthoboric acid. You will get, that is very, very important. How do we get orthoboric acid? From alkene. They may ask such kind of question also. Hope you're clear. So this is the first step. That's what two molecules of alkene combined with diborane, you are getting this product. This product again, it reacts with the excess of alkene. You are getting double two times. Okay, then until it has to remove that hydrogen. Now primary, secondary, tertiary, like that. Now again it reacts with here. I just started from here, so that to what it is, you will get the product. Now here, this is the product, you will get it. So here CH3, CH2, CH2 thrice, be that hydrogen has gone out. Okay, now this one reacts with hydrogen peroxide. You are getting H2O2, right? So this one, you are getting what it is, CH3, CH2, CH2OH plus H3BO3. Hope you're clear with this. Now, the next question, it's very interesting. How do we get alcohol from carbonyl compounds? What are the carbonyl compounds? Aldehydes, ketones, ester, carboxylic acid. These are the carbonyl compounds. We are having another topic only, aldehydes, ketones, carboxylic acids. Yes, come to this point. How do we get alcohol from these? Okay. Now, first and foremost, I would like to give the keyword what it is, reduction. What are the reducing agent? Lithium aluminum hydride, nickel palladium, sodium borohydride, and sodium with ethyl alcohol. These are the any one you can utilize as a reducing agent. Okay, now aldehyde. The first one, what it is? Aldehyde. Aldehyde. So aldehyde, what it is? CH3, C double bond O H. CH3, CHO also you can write it. Just I mentioned the double bond because it's a carbonyl compound. So I mentioned that, and reacts with what it is, hydrogen in the presence of nickel palladium. I just mentioned nickel palladium. So what happened here? You are getting CH3, CH2, COH. Okay, so how many carbon is there that you will get the straight chain? Okay, that many, what it is, carbon along with OH, it will be attached. So ethyl alcohol, two carbon, ethyl alcohol. Now the second one, ketone, I just take it, CH3, C double bond O, CH3. This is ketone. Acetone also you can say. Dimethyl ketone also you can say. So this is also carbonyl compound. That is what I just mentioned. C double bond O, C double bond O. It's a carbonyl compound. Purposely I just mentioned. Okay. Now hydrogen in the presence of nickel, palladium. Okay. So this is actually aldehyde. This is ketone. Ketone. I just mentioned very clearly for you to understand. So this is ketone reacts with hydrogen in the presence of nickel palladium. You are getting isopropyl alcohol, CH3, CHOH, CH3. Now you see here straight chain you are getting, but here you are getting a branched chain. Why? Because there is a mechanism I will give you later as we finish. According to this, we will go for that mechanism. It's very interesting. Okay, now the third one, what it is? Aldehyde we finished, ketone we finished, carboxylic acid. So carboxylic acid, CH3, C double bond O, OH. See, purposely I just mentioned C double bond O. See, wherever C double bond O comes, that is carbonyl compounds, and it reacts with reduction reagent only. So here I just put it this way: hydrogen in the presence of lithium aluminum hydride. Anything you can take it. Lithium aluminum hydride also you can take it. Sodium borohydride also you can take it. Nickel with palladium also you can take it, or sodium with ethyl alcohol. Anything you can take it according to that. Okay, so what you will get it? CH3, CH2OH plus H2O. You will get it. Okay, now the next one, fourth one, what it is? Yes, sir. So aldehyde, ketone, carboxylic acid. This is carboxylic acid. Okay, now carboxylic acid, I just have taken what it is. Acetic acid, CH3COOH, acetic acid. This is ketone and this is aldehyde. Ketone, you see what is the formation? CH3, CHOH, CH3. This is isopropyl alcohol. Whereas aldehyde, it gives ethyl alcohol. Please mention how do we get isopropyl alcohol? Compound gives that isopropyl alcohol. Which one? It is like that. They may ask the question. Compound B gives. Compound B, actually what it is? Isopropyl alcohol. That means compound A, what it is? Such kind of question also. That is what it is under H2, nickel, palladium. Such kind of questions they may ask. This is nothing, ketone. Okay, now next one, carboxylic acid. Then last one, what it is? Ester. Actually, ester, it is faster than acid. So ester, CH3, COO, C2H5. Okay, methyl ethanoate. Okay, it is combined with hydrogen. I just put it like this way only. Lithium, aluminium hydride. Okay, so what you are getting here? C2H5OH plus CH3OH. So you will get two kinds of alcohol, CH3OH and C2H5OH. How to differentiate? According to that boiling point only. First one they will suck, the another one it will be remaining in that bottom of the flask only. Okay, now come to this point. This is methyl ethanoate. Okay, so ethyl methyl ester also we can say. Okay, so this one reacts with hydrogen in the presence of lithium aluminium hydride. You are getting ethyl alcohol as well as methyl alcohol. So these are all the points comes under carbonyl compounds. Next, one more point, what it is? Using Grignard reagent. So in that we are going for carbonyl compounds. Along with that we are adding Grignard reagent and we are getting alcohol. Right, now this is the reduction process. This comes under reduction process. Another one more reaction, it is carbonyl compounds react with Grignard reagent. You are getting alcohol. How do we get that? That is what we are going to see today. Okay, the next question, it's very simple. How do we get alcohol? Using Grignard reagent from carbonyl compound. Okay, it's so simple. You know, aldehydes and ketones only will take part in this reaction. Okay, so aldehydes or ketones reacts with Grignard reagent. You are getting addition product. That addition product undergoes acid hydrolysis. You are getting what it is? Alcohol. Okay, now actually this is a two-step reaction. Now that first one, it is RMgX. It is a Grignard reagent. I just put it CH3MgBr. Okay, methyl magnesium bromide. It is nothing. Grignard reagent combined with formaldehyde HCHO. C double bond H. So HCHO. This is nothing, formaldehyde. This is nothing, what it is? Formaldehyde. So what happened? You are getting what it is? Addition product. What is that addition product? Here CH3, C, here one hydrogen, here one hydrogen, here O, Mg, Br. Combined together, add both the thing, it will be add and you will get that addition product. So this addition product undergoes acid hydrolysis. Okay, so what you will get the product? CH3, CH2, OH plus Mg, here OH and Br. Okay, now this Br comes here. Actually magnesium valency too, so you are getting such kind of the product. Okay, now the next one here, what we want, that alcohol. So methyl magnesium bromide, so propyl magnesium you are getting what it is? Isopropyl. Next one more example we can, bromide. Okay, this is isopropyl magnesium bromide combined with formaldehyde, the same double bond, hydrogen this side, HCHO, formaldehyde, HCHO, HC double bond, a carbonyl compound. That is what purposely I just mentioned, and you will get what it is, the product, addition product. What is it, addition product? Here CH3, CH, here CH3, the same you just mentioned, and come to this hydrogen, here hydrogen, here hydrogen, here OMGBr. Okay, so this is the addition product. Now, acid hydrolysis you are getting. Acid undergoes acid hydrolysis. Okay, so what you are getting? CH3, CH, here CH3, and here C, hydrogen, here hydrogen, here OH, isopropyl alcohol along with Mg, the same OH, and here Br. See, whenever you are writing, you just check it whether the carbon is attached with 4 bonds. Now 1, 2, 3 along with hydrogen 4, here 1, 2, 3, 4. Okay, now like that. So CH3, CH3, CH2. Okay, OH. So this is isopropyl alcohol. Okay, hope you're clear with it. Okay, now next to one more, cyclohexyl. Cyclohexyl also we can. Hope you're clear. Yes, I'll go for another example. Instead of isopropyl, I just mentioned cyclohexyl. Cyclohexyl magnesium bromide. Okay, cyclohexyl magnesium bromide along with HC double bond OH. Okay, this is HCHO. It is formaldehyde. It gives what it is. Here I just mentioned here only. Cyclohexane. No, this again here carbon connected with what it is, one hydrogen, here one hydrogen, here OMGBr. This is what it is, cyclohexyl magnesium bromide. Grignard reagent along with that formaldehyde, HCHO, formaldehyde. This is carbonyl compounds, right? So you are getting what it is, addition product. What is that addition product? Cyclohexyl magnesium bromide. Okay, now here this is actually addition product. Now again it goes acid hydrolysis H2O along with that acid hydrolysis. What happened here? So here C hydrogen, here OH. So hexyl methanol along with Mg, here OH, here Br. Hope you're clear. This is very simple. Whatever it may be, Grignard reagent, whatever it may be, combined with the aldehyde, you are getting attached with that what it is, addition product, completely addition product. Then it undergoes acid hydrolysis. You are getting what it is, the great alcohol we are getting and side product. Hope you're clear. Now aldehyde only we have seen. Now we are going to see that ketone. Other one more, it is ketone. By the time you yourself come to know that is methyl magnesium bromide, CH3 MgBr, right? CH3 MgBr combined with acetone, CH3 C double bond O, CH3. Okay, so CH3 C double bond O, CH3, it gives what it is, addition product, that is CH3 C, here CH3 and here CH3. This CH3 comes down, this CH3 goes upwards, and this is OMGBr. Right? This is OMGBr. Is it visible? Yeah, this is the addition product. Okay, now this addition product, it goes what it is, acid hydrolysis H2O along with H plus acid hydrolysis. You are getting what it is, tertiary alcohol. So whenever ketone is there, number of what it is, alkyl group is more. So you will get what it is, tertiary alcohol. So CH3, here C, CH3, here CH3, and here OH plus Mg, here OH and Br. Okay, this is acid hydrolysis. And see, whenever goes for the ketone, you will get alkyl group will be excess, whereas aldehyde alkyl group only will be what it is, isopropyl, like that will be coming. But whereas ketone you will get both. And how to identify, this carbon has 4 bonds, whether it is there, yes, it is attached. Okay, so this is tertiary. How do we get tertiary alcohol from ketone? Such kind of question also we can get that kind of question. Okay, hope you're clear with it. Whatever we have gone through that. Thanks for watching.